When I started in the internet, I was selling some of the first application servers back in 1999. The expectation was that a page would load in about 7 seconds. Now we're down to 3 to 2 seconds, right? Amazon and a bunch of companies see people getting frustrated. Like imagine you put up an URL on your computer, you wait 1, 2, 3 seconds, think like something's wrong. Like, is my connection wrong? Is the website not good? Do I really want to do business with this? Like not only the staff at the top, but Salesforce Research interviewed about thousands of people around the world, and they found that bad digital experience is the main reason why people switch banks nowadays, right? So the problem is, we've been doing monitoring for a long time, and we have not only slow experience because slow is the new down, but also we have a lot of outages. So like every week you can just watch the news and you'll see news from companies going down. I just put a couple examples here. These are mostly CDNs, and not to pick on any one of these. Even at Rackspace, where we provide 100% SLA, we had downtime. The point here is that even for the largest companies that have armies of very smart engineers and incredible tools and investment to maintain uptime, they have downtime, they have incidents. So the question is not if it's going to happen to you, but when, how long, how often. Recent research from Forrester shows that for retailers, the average retailer has dozens of incidents of different severity every day. And this is even more problematic now that we have also distributed workforce, right? So even for the individual employees that are working, like I'm working from home right now, right? And I'm connected through the internet via Zoom. There are hundreds of things that need to happen for this Zoom conversation to be happening right now. And so the challenge to this is that the internet is the fabric of your applications, right? The internet is more complex and more fragile than what we realize. We analyzed, just out of curiosity, looked at some of the most popular websites. I found that CNN's website, just to load, has 630 different calls. Like one call could be Adobe Tag Manager, maybe loading fonts from another website, loading images from different sites, videos from yet another one, CDNs, advertising tags, JavaScript calls from different places, etc. And all that needs to happen in 3 seconds, right? So the point here is that everything has become internet-centric, distributed, and service-oriented. And so if you look at even just, again, not to focus too much on websites, because we're talking about all kinds of applications and APIs, but even just from a web performance optimization perspective, it's getting a lot more complex, right? There are new protocols like HTTP3 and QUIC. There are new technologies like IPv6 that sometimes need to be managed differently. Companies need to be concerned about things like Core Web Vitals and Lighthouse metrics for a website for ranking on search engines. You have now XLOs, which we'll speak about in a minute, performance, CDNs, DNS, BGP, SSL, APIs, etc. Right? So it's websites themselves, which used to be very simple, are now getting more and more complex. But it's not only website, right? So if you think about a bank, banks used to have their own applications hosted oftentimes on premises, which on premises means obviously a data center. But think about the new banking system today. You have a CRM, right? So they have their own database for their customers, and everything they do needs to be activated through identity, which could be in the cloud, for example. You have multiple databases and replicas in different places in the cloud. You might have a database as a service as well. You have DR sites for every one of these things. Probably has a DR site or a backup somewhere. Then you have SASE to allow, or VPNs if you're old school, to allow people working from home or even connectivity from some other bank office. You have a firewall. You have then for banking, you have banking APIs for Venmo or transferring money to ACH or SWIFT. There's open banking APIs that are becoming a standard. There are digital banking platforms, card issuing bank platforms. There are also trading platforms for buying stocks. You have security technologies. You have trading APIs. You have the connectivity to your branches. You have the connectivity to ATMs. You have your website, and then you have users in different devices all over the place. And each one of those connections, as you can see, depends also on DNS, of course, because DNS seems to be the most common problem nowadays, but also things like certificates. We work with one of the largest banks in the States. We monitor, I think, about 25,000 certificates every day. And it's surprising how companies, sometimes they don't have a good database of their certificates. One of them expires, and one of these connections goes down, and the bank stops, right? It can be something as simple and trivial as renewing a digital certificate, and suddenly your bank stops working, because everything, again, is complex, distributed, multi-cloud, API centric, internet centric, and evolving all the time, right? And so the challenge of all this is depicted in this concept that we have, that we call the internet stack. So the internet stack is analogous to, let's say, an application stack, where you have typically code, databases, infrastructure, et cetera, and bare metal, or could be analogous to the OSI 7 layers of networking. But the idea basically is to recognize that there are multiple layers of technologies, protocols, and systems that modern applications and modern businesses rely on to operate, right? So every business today is not like in the old days. When I started my first job here in Austin, we had a server room where we had the mail server, Exchange, we had a print server, we had a file server, we had a LAN with Wi-Fi, and everything was in that room, right? Like the IT person lived in that room, and as long as the stuff in that room worked, the company was okay. You probably had Siebel on premises. Now that's gone. I cannot think of a company that has a server room like that with most of their applications. They might have a handful of them, then they're probably going to be in the cloud. A lot of them is going to be SaaS. And there's so many different technologies that people need to pay attention to, right? So I'll give you an example. BGP is one technology that a lot of people were not even aware of what it is. It's basically the zip code system of the internet. 3 years ago, more or less, we had a situation where in the morning you wanted to check Facebook and it was down. You wanted to chat with your friends on WhatsApp and it was down, and Instagram was down as well. All the systems at Meta were down because their BGP system was failing. And this could be for human reason, misconfiguration, and error, or it could be malicious, right? The BGP hijacks are now a thing. So if your BGP is down, your zip code is down, you cannot get mail. Their IT people are having trouble even walking into their data centers because their key cards could not authenticate their identity to their identity servers, right? So the point here, or the moral of the story, what I'm getting at, is that there are technologies like BGP that maybe we didn't think about 20 years ago, 15 years ago, 10 years ago, that are becoming really important. And the more that we rely on the internet technologies, third-party distributed, the more that we need to pay attention to things like DNS, Quick, SSL, once, your own LAN, etc., all those things. So just like for years, we've had this application stack that we monitor with application performance monitoring tool, which are really critical. But they're also 30 years old, right? Like when first APM tool was developed by Wiley, it was a world where we had all those servers on premises. And yes, APM tools have evolved, and they've added a lot of capabilities, and that you can monitor cloud systems and Kubernetes, and they become much better what they do. But the fundamental premise of APM is still an application stack. So think about it. It's really melt, right? Infrastructure metrics, right? So you're looking at the bottom of this stack. You have code traces, right? The core of the application. You have logs. You typically only get logs for the things that you have in your own stack, and events. And these systems traditionally have been blind to all the things that happen in the internet, which is what we're talking about, the internet stack, right? So you need a new type of tool, internet performance monitoring, to monitor the internet stack. So let me go into a bit more detail. Just like you have APM for the application stack, you have IPM for the internet stack. And yes, you can use even some of the same tools to capture data, like synthetic monitoring, right? Or the methodology and how you proactively do tests might be similar, but there are actually very, very important differences that I'll explain in a minute. So let's define internet performance monitoring. is the ability to monitor all these technologies in the internet stack, so you can catch issues in whether it's your own customers. If you have a website, could be partners. If you like have a, I don't know, you're a B2B, you're working with your suppliers, or you're a bank and you're working with other providers, your workforce, your employees that are distributed or even in different offices, applications themselves, and that includes APIs, right? So for example, one of the use cases of IPM is a large automotive factory where they're monitoring the connectivity between the robots in the factory, robots on their central command center, the command center on the cloud on the cars. All that system is being monitored. It's all APIs and it's all devices. The network itself and the experience of people using a website. And the goal of all this is to be able to catch those incidents before they actually impact your business, right? And so Forrester Research has been saying that companies that do not invest in IPM are vulnerable to huge financial losses, right? So they're establishing the importance of IPM as something new, something that companies need to pay attention to. So let's talk about what makes IPM. How do we define IPM? The first thing, there are three things that make IPM effective. The first one is monitoring what matters, right? So we talked about the internet stack, that set of protocols, technologies, and systems that you need to look at. But an important approach is that instead of thinking about from an infrastructure perspective, as you can see in the bottom here, where you start with infrastructure, again, if you think about Melt, they're very system-centric. They're very focused on, how's the server doing? How is my CPU? I used to be at SolarWinds. We sold a lot of database performance monitoring, right? So we talked a lot about database wait times. And we provide a lot of server metrics and network device uptime, configuration, very infrastructure centric or network centric. The best case, those systems are application centric with a little bit of end user, right? But what if you flip this the other way around? Because at the end of the day, the goal of IT is not to maximize CPU utilization or reduce the number of wait times in your databases. The goal of IT is to enable the business, to make sure that your users, whether customers, employees, or your employees, customers, or APIs, they can consume the services, the applications you're publishing, and do it in a way that is reliable, consistent, and performant, right? So that's what we call being resilient, the four aspects of resilience. So if you flip this inversely, what if you start with the end user first and understand the end user perspective first, and then understand how is that end user experience being enabled by services, clouds, external services as well, then networks, applications, and infrastructure. Keep in mind that in a modern world, your own infrastructure, your own applications are going to play a lesser role than all these other services, right? So think about the diagram I showed a minute ago about a bank, right? The bank's own applications are going to be, from a reliability or dependency perspective, risk perspective, maybe 10% of the risk, maybe 10% of the failures are going to be on your own applications. And that's partially because APM's gotten so good, right? So APM is great. Cloud systems are being very resilient, especially if you architect them with multiple availability zones. And there are a lot of technologies now to make applications resilient. So the biggest challenge here is this middle block here with services and third parties, things that you need to pay attention to. Now, if as an IT system, as an IT organization, if you're thinking about SLAs, like, my databases are going to be 99.99, 4 nines in my databases. That's my SLA for the business, right? You think your CEO really cares about your database uptime, or they care about, can my customers come to the website and transact? Can my warehouse detect that we need to order more inventory and set up an EDI request to a provider to get information? Can we complete a transaction at the bank in 100 milliseconds so that we can get ahead of the market, right? Those are the things that customers, that CEOs, that the business really cares about. So if you think about end user first, you have the opportunity to evolve from infrastructure-centric SLAs to user-centric XLO. So what is an XLO? An XLO is an experience level objective, right? So it's, instead of defining your objective as an IT department, again, as we're going to use 90% server uptime, or we're going to reduce our cloud cost by 5% this year. You define your objective as, we're going to make sure that our mobile banking users on a mobile app can log in, check the balance, and make a transfer in 5 seconds. Or we're going to make sure that our traders on the floor can log in, complete a transaction, do a query of any stock, and complete a transaction within 2 seconds. You're a rental car company. We're going to make sure that somebody walks up to the counter, and instead of the typical, sorry, my computer is slow, they're going to be able to give them the reservation number, and the person helping on the other side are going to be able to pull up the number, print their contract, get it signed, and hand them the keys within 15 seconds, right? That's an experience level objective. And so IT is the enabler of that objective. And that completely changes the mindset of IT and creates incredible alignment between IT and the business. The goal also of monitoring what matters is to get that true visibility of anything that could impact that experience, right? If you're thinking about that rental car counter, you have a user and there's a computer on the other side, and there needs to be a connection, typically wireless, and then you have an ISP that you might have if you're in the US, could be AT&T or Verizon or Lumen or any of those. All the information goes to the backbone, to multiple cloud services, to your own servers, to your own code, to your database. So if you start with an end user perspective as the end goal, and then understand all the things in that process, each one of those things, how do they impact that performance, that experience, including the code and including your databases, that's really true end-to-end visibility, right? A lot of people talk about full stack visibility, but they're only talking about the last 3 things on the right of this diagram. To really understand your users, you need to have the full picture, because all these things, even if they're not necessarily part of your own responsibility or fully under your control, they're still your responsibility as an IT person to make sure that they work, right? The second thing that makes IPM effective is monitoring from where it matters, right? Understanding the real world experience of users and the impact of the internet. So that's another challenge of APM tools. Again, they're great. They can do tests. You can do synthetic text from the cloud, which are great from a QA perspective, right? You create new code. You want to make sure it performs well. You're checking continuously from a cloud server. It's good from a developer perspective from QA. But if I'm coding here in Austin and have a user in New York accessing my application through, let's say, a Verizon wireless device, do you think that the experience inside an Amazon data center is the same as a user on a mobile device? Evidently not, right? Like, it's not evidently that a data center has very different capabilities, performance, network connectivity, different type of issues, right? But also there are many things that can go wrong between the connectivity between my cloud service and the end user. And in a world where there's routing and ISPs and different performance things, it's very common to see the performance of people in different places in the world is going to be very different. Problems can be regional, and those are the hardest to detect. We worked with Sony. They were having some issues with PlayStation. The 3rd largest market for them overseas was a market where they were having issues where their customers are complaining all the time, and their IT team was saying, like, look, everything looks green on my dashboard, so it must be user error. And the business was saying, no, our customers complain all the time. Your systems are not working well. And so the problem there is that what you're looking at is not necessarily what users are experiencing, right? And so once they installed an effective IPM tool at Sony, they were able to detect that one of the gaming applications was configured in that region incorrectly. So it was downloading the graphics from a CDN in another part of the world. And that was injecting a lot of latency and slowness to the games. And if you know anything about gamers, is that latency and performance is critical for them, right? You want, when you're playing a shooting game, you want the bullet to arrive before the person can move. And if they're shooting you, you need to be able to move around and avoid something. Anyway, so the story here is that performance, the regional expectation, the real world monitoring of users is critical. And so at Catchpoint, we have the largest network of intelligent agents, right? So while the typical APM tool has, let's say, a dozen, maybe, I think the largest one has 3 dozen locations where you can test from, all of them inside a cloud hyperscaler like Amazon or Google Cloud or even Alibaba. We have 3,010 intelligent agents, right, located in 106 countries. And so this is important for multiple reasons. The first reason is that we know we can show the real world experience of that person in New York on a mobile device, whether they're using Verizon, how is it different from somebody using AT&T? How is that different from somebody working inside an office with connectivity to Spectrum? But we also have agents in the backbone and last mile, wireless agents, BGP peers, cloud agents, right? And we can deploy also enterprise agents inside a building, or even in a router device, or even in each one of the laptops of that person working in the rental agency, right? We can deploy a device in each one of those. We do this with banks, right? So you open a bank at, I don't know, 9 o'clock in the East Coast, thousands of bank locations open. At Bank of America, you don't want people to try to log in and say something's broken. Now you have a line of customers, everybody's frustrated, thousands or maybe millions of dollars impact to the bank. So in the case of Bank of America, they check from each location, each actual branch, simulate a user logging in, doing a transaction, logging out every 5 minutes continuously. And that gives them the confidence that when they open the doors at 9 o'clock, the bank is going to be able to operate. That means also that if something happens at 3 o'clock in the morning, we will catch it within the next 5 minutes, and IT will be able to detect it and fix it by maybe 3:30, way before the bank opens. It means also that if there's an incident in a location, IT is the first to know before customers detect it, before it escalated, before it has the opportunity to create more damage to the company. And the third thing that makes IPM effective is precisely this concept of being able to catch incidents before they become incidents, right? So how this trust, this uptime can become a competitive advantage for your business. And basically here, it's a broad collection of technologies and systems to allow you to act on the data that you're collecting, the things that you're monitoring from where it matters, to basically be able to act quickly. So here's a day in the life. Like if you combine all these things together, instead of getting an alert says like, CPU is down, I don't know, CPU in this server is 89%. Yeah, you probably need to check that. But is that really the most critical thing? Now imagine a dashboard that takes that approach and you get basically an experience scores, right? So we use AI, no surprise there, to calculate experience scores. Or this can be your XLOs, right? How are my users in each one of my offices being able to experience my systems, right? So you can see here that London, Chicago and Dallas, there are probably some things that we need to optimize, but London is really where you need to focus on, right? So instead of getting thousands of alerts of, a lot of little things going bad, you can see immediately that you need to focus on London. And of course, there are alerts when this experience reaches the threshold that you can configure that connect automatically with your other systems. This can be exported to your APM system if you want to use that as your main control panel. These dashboards could be configured to be regional or by application or by team. How is my sales team doing versus my, my IT team versus my operations team, manufacturing team, etc. And then it's okay, there's a problem here. What's the root cause, right? So first thing is be alerted of the problem quickly. The second thing is, okay, is this our problem or not? So we have a system that is continuously monitoring hundreds of services around the world to identify if anything's wrong, right? So as an example, we had our website at Catchpoint went down one day, and I started getting pings on our Teams chat saying, hey, our website is down. So the first thing that my team was doing was they're opening a ticket with our website provider, right? So we use a hosting company, we use Webflow. And so they were opening tickets with Webflow. And I launched our service, and I saw like, oh, Amazon West, I forgot which one's the data center, is down. Since our website is hosted there, evidently it's not a problem of Webflow, it's not our problem, there's nothing we can do, we just need to wait for Amazon to be back up. I'm sure that every other website that Webflow is hosting is having the same incidents. So now I know that it's not my problem, or at least I know what is the root cause of the problem. This is a screenshot I took just about a month ago, And we found that DigiCert was having some issues and Klarna was having some issues. So if you're a retailer, this is very important for you to be aware of, right? So I'll tell you another story. There was a time, I think this one was about a year ago, where Adobe Experience, I think it was a tag manager, had some incidents. So at the time, we had just launched this, and we had one of the largest sneaker brands were using our technology, and they alerted this tag from Adobe went down. In fact, there's a blog post on our website if you care about this story. And so this company found, okay, if this is down, we'll just modify the website to not use it for a moment until they come back up. They made the change, pushed it to production. 3 minutes later, the website was up. Everything was fine. Nobody even noticed a blip. I'm sure there was a little bit of hiccup on traffic. Other companies were not aware of this, so they had to wait until people started complaining. The same chat, like, your website is down. You typically go and check it yourself. Yes, it's down. What do we do? You call a war room, and what does our APM say? Like, APM says everything is great. All right, let's start going like elimination, right? One by one, all the things, all that list of dependencies of your website. What is the problem? And it took them, at the first pass, they actually checked the Adobe status page. Adobe status page was not even reporting at that time. So they were not even, they're not aware that was a problem. So they had to go back until the second pass. They actually were able to catch it. And an hour of downtime for a retailer can be very, very damaging, not only from the lost revenue, from the lost trust as well. So this is a system that will alert you of external systems. But what if you could see everything in one dashboard, right? So imagine being able to see from the end user, in this case, you have a front-end server, you have your DNS systems. For different technologies, you might have multiple DNS systems. You have third party, here's a tag manager, here's like even trivial things like Twitter, etc. Those things can bring down a website as well, right? Your origin APIs, your gateways, some of your backend services, your database, and your microservices, right? So here you can see the entire system from the end user all the way back to your backend systems to identify, okay, we have a problem in our database, right? And you can see here, well, there's 1.3% downtime. Here's the packet loss. Here's the status of each one of the systems. You can look at this over time. You can see your availability. You can drill down into any of these things. So basically, you go from, okay, we know we have a problem in London. There's not a problem in our services, in the main service that we rely on. Okay, let's look at the map. Okay, here's the problem. It's a database problem. Right now, you can talk to the DBA, get it fixed. It can take you 10 seconds to do this, right? So at the end of the day, what we're saying is that, you still have probably a lot of NPM tools that are, I used to, like I said, I used to work at SolarWinds, focus on SNMP, your local LAN. There's traffic and flow, very, very network device centric, right? So they're not geared to monitor the internet, none of them. APM, essential. Every business needs one. A lot of consolidation in this market. There's probably, this chart could have also a long list of different APM tools. Focus on melt or trace logs, traces, and metrics. And last, internet performance monitoring, which focuses on the end user, customer API experiences, thinks about the global internet and your workforce, looks at the internet stack. And there are only two companies that do this, right? It's Catchpoint and Cisco. Everything I mentioned. Obviously, I use the stats for Catchpoint. We have 3,000 and change nodes. Cisco has 1,000 eyes only. And they have obviously some other differences. But we're not the only company, right? Like there's recognition that this is something that's important. I think most companies today will need at least APM and IPM to be effective. If you have a large network, you likely also will need some NPM tools, which everybody knows, and they're already, very, very solid products. Not a lot of innovation there, not a lot of changes. That's all a problem. Let's talk about two good examples. SAP Commerce, specifically in Germany, largest European company based on valuation, started using Catchpoint and Dynatrace. They actually combined Dynatrace and Catchpoint, and they actually call their team, I think, is AIPM. So APM plus IPM, that's how they define their own team. The SAP Commerce manages probably 10,000 different retail stores around the world. They need to be up all the time. And as they combine this APM and IPM together with their own secret sauce, look at MTTR, 300 minutes to 20 minutes. SLA violation from 16% to 0.2%, right? Major incidents, half of them. Customer incidents, a third of them. So the impact has been dramatic, right? Not only for the business, for their customers as well, and also for the individual who built this program, this technology and this system. He's a hero, or maybe more accurately, he's now a leader in that company, right? Let's look at IKEA as well. IKEA, I like in particular, because by taking that experience, that concept of IT is here to serve the business, and observability is not just to observe your engine, is not to look at server metrics or look at code traces. Is really about operational intelligence, right? So they redefine the business to focus on operational intelligence and customer excellence. So they are completely enablers of their business model. So IKEA uses IPM so that every one of their 180,000 employees who uses a laptop has an IPM agent, so that they can ensure that whether they're using Salesforce or Office or Teams or whatever they're using, it works well for everybody in all countries. This is also including, the kiosk. When you walk into an IKEA, there's a system to design a kitchen. There's some other tools you can use inside the store. All those systems are being monitored. They also protect their website for performance and uptime. And they use this to improve not only SLOs and SLIs, but also overall the operational experience, right? So you go to an IKEA, and on your app you say, I'm here, I'm going to pick up my furniture. That system that sends that information to the backend person receives it. They grab the things from the warehouse, they pull out the cart, they deliver that to you. All that process, not only the IT systems, not only the servers, not only the code, not only the logs, that entire human experience process is being monitored and observed through this operational intelligence system, right? So it's a wonderful example. And so when we were talking about these 4 pillars, I started talking about digital resilience. The 4 pillars of resilience are reachability. Can you get to it? So if it's a store, can you actually drive to the store? If it's an IT system, is it reachable through DNS, SSL, etc., ISP? Second, is it functional? Are all the things in that system completely functional? So if you go into the store, do the checkout work? Do the kiosk to design a kitchen work? The third one, is it performant, right? Because if I go to the kiosk and I say I want to design a kitchen and I enter something, again, at 3 seconds, I'm starting to get nervous. I'm starting to like, maybe this thing doesn't work. At 5 seconds, I say like, I don't like this. At 7 seconds, I probably close the window, moved on, and decide to buy my kitchen somewhere else. So performance is the third pillar of resilience. And the fourth one is reliability. Can you count on the system to be performant, accessible, and functional all the time, always, over the time that it's really critical for your business? And so how is this IPM being adopted? So it's relatively new, but 9 of the top 10 Forbes digital companies are using it. All the cloud providers like Azure, Azure, GCP, and AWS, they're all using Catchpoint IPM internally. All the top CDN providers, all the 7 of the top 10 publicly traded software companies, all the largest e-commerce platforms. So Walmart uses Catchpoint, SAP Commerce, Salesforce Commerce, Shopify. And Gartner has recently published a Magic Quadrant for digital experience marketing for the first time. And this is important. Obviously, we like that we're in the leaders quadrant, but it's important because they're establishing the importance of this idea of digital experience monitoring, right? This is the first time they publish a quadrant. And it's also important because it recognized the role of internet performance monitoring in particular, right? So within the concept of DEM, they recognize that there's this thing called internet performance monitoring to analyze this third-party systems, including this border gateway, which that's a mistake on their side, DNS, etc., all the things that we talked about, they are establishing this is something that's really important, and obviously we have, as Catchpoint, we have a high rating on this subset of DM as well. So in summary, ensuring internet resilience for reputation, for revenue, for aligning your business the goal is to monitor what matters, the internet stack, all those technologies that matter, from where it matters. Sorry, I had to upgrade. We're adding notes very quickly, so I forgot to update this slide. And to get to the answers faster, right? Get the AI-assisted tools to find the root cause, to identify the problem, to explore your data with end-to-end visibility, right? And so now we're reaching the end of our presentation. So there'll be a poll. It will take you just 1 minute. We would appreciate very much if you answer just one question that is being presented to you in this poll. And we'll be using your answer to help us, if you found this interesting, to give you the information you need. And while you answer that, I'll leave you with one last thing. We talked about Forrester, we talked about Gartner. Here's a quote from GigaOM Research. And it says, IT decision makers need to make a decision. They must choose. They can either bear the full weight of outages, or they can invest in an IPM solution to navigate them intelligently. So in other words, if you're intelligent, you would invest in an IPM solution so that you don't have to bear the weight of these outages. In other words, don't wait until there's a major outage and your company is in the news, like Southwest Airlines and other companies that, you can open any news that you like, and you'll probably find one. And but you can instead invest in those in an IPM solution, so you have that visibility into the internet stack. And again, this is not only Catchpoint, right? There are alternatives. So it's really important for any business which is digital. Every business is now digital, to invest in IPM. We think Catchpoint is a good alternative. So let me know if you have any questions. I'm looking at the chat. If you have any, so first, thank you for sharing your opinion on the poll, and we'll be happy to give you more information. If you have any question, there's one question on the chat at the moment, and he's asking about the difference between DEM and IPM. It's a great question. So Gartner defined DEM as a broader set of understand digital experience, right? So it's basically the idea of you need to understand the perspective of a user accessing your application. And they have this magic quadrant with the top 3 APM vendors and Catchpoint, right? And then there's IPM, and Gartner thinks about it as a subset of DEM. We actually think about it the other way around, because IPM is a broader set of technologies that look at all this internet stack, right, from where the users are. And that's the main difference. Like Datadog, Dynatrace, New Relic, they try to look at it from the customer perspective, but they don't have the full context of the internet stack. They don't have, like we were talking about, the broadness of let's say, BGP. We have, as you can see here, 1,600 BGP peers, so it's a bit grayed out, 487 ASNs that we're monitoring in real time. So if something happens in your BGP, we can tell you in real time. There's not a company in the world can do that. Dynatrace and those companies are blind to BGP, basically, right? So they are limited in the sense yeah, they're trying to understand digital experience because they offer RUM and synthetics, but they don't have context of they don't meet this criteria of monitoring what matters and monitoring from where it matters, right? So they don't really understand the internet stack fully, and they don't have the node of networks. And their tools are, honestly optimized for system level visibility, right? So if you look at every new release from New Relic, they talk about what they're doing different with logs or code traces or Kubernetes, great advancements in that area. The only thing that Catchpoint thinks about is the internet. Everything we release every quarter is focused on internet performance, right? So our focus is very different, and that is the main difference. If there are no other questions, I want to thank VIB for scheduling this webinar, and thank all of you for your participation. I hope this information has been useful for you. And if there's anything we can do to help, please let us know. Thank you for your time.
Awesome. Thank you so much, Gerardo and the team at Catchpoint. With that, we'll go ahead and close out the webinar today. If you have any questions, of course, for VIB, you can always reach us at webinars@vib.tech. But if not, I hope everyone has a wonderful Wednesday and a wonderful rest of their week. Bye, everyone.